my dear students, let's start the session.
Now we need to talk about radius of curvature. Okay. So what is the radius of curvature? How to calculate radius of curvature? So now we can take one arc like this. It is going like this. Like this. Okay. Here to here. Draw random arc. So how to calculate radius of curvature? How to calculate radius of curvature? Radius of curvature. Write down. Radius of circle fit into the arc. Radius of the circle. Radius of the circle. Radius of the circle. Radius of the circle fit into the arc. Fit into the arc. Fit into the circular arc. Fit into the circular arc. So what is the radius of curvature at this point? Here we need to write the fit into this. Okay, this much circle we can fit. This much circle we can fit. Here, this much circle we can fit into the arc. This much circle fit into the arc. Clear? This is the arc. This much circle fit into this. Radius of curvature. Radius of curvature fit into this. Understood or not? Here to here. See this. Here to here. How much circle we can fit? So this is the radius of curvature. R1. Radius of curvature R2. Radius of curvature R3. R3. Understood? R3. Clear up? So if the particle is here, if the particle is here, mass of the particle m, it is moving with a velocity. It is following the circular path. This is the velocity v. Velocity v equal to how much? This is the radius of curvature v2 r2 omega. R2 omega. Understood? So here centrifuge always at vertically downward direction. Centrifugal forces act always act away from the center of circular motion. Away from the center of circular motion. That is Fc2. M into V2 square by radius of curvature R2. Corresponding radius of curvature we need to take. Clear? Radius of curvature calculations. Radius of curvature calculations in projectile motion. Radius of curvature calculations in projectile motion. See this, projectile motion. Here to here. Okay, so here this would be rectilinear translation along y-axis, rectilinear translation along x-axis. Here to here, this is the projectile motion. Projectile motion at the point of projection. So, what is the radius of curvature of the ball or point mass? At the point of projection, this would be theta. It is projected along this direction. Okay, so we need to draw first perpendicular to this. Perpendicular to this. Okay, this along this somewhere center of the circular motion. Clear up? Then fit into the arc. Okay, so we need to draw the circle. We need to draw the circle. It can fit into the arc. We can draw the circle. It can fit into the arc. That is the radius of curvature. That is the radius of curvature. Understood? See this. Here to here. Fit into this. Fit into this. So here to here how much? Theta. So weight always at vertically downward direction. Weight always at vertically downward direction. So if it is theta, this is 90 minus theta, this would be theta. Correct or not? If it is theta, 90 minus theta, here to here. Understood? So if it is theta, 90 minus theta, then 90 minus theta, entire part is 90. This is theta. Mg cos theta. Along this direction, what you will get? This is what? Radius of curvature. So what is the, how to draw this? Mg along this direction, what you will get? Mg cos theta. Mg cos theta. Along this direction, Mg sin theta. Along this direction, Mg sin theta. Circular motion. It is in the circular motion. Radial acceleration towards the center. Centrifugal forces are acting. Centrifugal force is acting. M into corresponding V square. Corresponding V how much? Corresponding V how much? V at the point of projection. Point of projection P. At the point of projection P, Vp equal to how much? U. Okay na? At the point of projection, that is how much? Vp square. Vp square corresponding radius of curvature at the point of projection. 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 Understood? Are you clear or not? Weight acting vertically downward direction. This centrifugal force is balanced by at the point of projection. At the point of projection. At the point of projection. Centrifugal force is balanced by whom? Centrifugal force is balanced by Mg cos theta. Centrifugal force is balanced by Mg cos theta. This is how much? M into Vp square. Mvp square by Mvp square by Rp. Mvp square by Rp. Radius of curvature at the point of projection. Mg cos theta. Mg cos theta. Clear? M gets cancelled out. This M and this M gets cancelled out. What is Vp? Tell me. What is Vp? Tell me. At the point of projection. Can I write U? Can I write U? Understood? Ardhamaitunda? So here Vp square by G cos theta. G cos theta, that is Rp at the point of projection. So Vp can be written as U square by G cos theta. U square by G cos theta, that is the radius of curvature at point of projection. Radius of curvature at point of projection. What is the radius of curvature at point of projection? Understood? Understood or not? Understood or not? Now, what is the radius of curvature at maximum height? At maximum height. here to here. What is the radius of curvature at maximum height? Radius of curvature at maximum height. Understood? So at this point, what is the velocity? Velocity at maximum height, that is equal to Vx, that is equal to Ux plus Ax into T. That part, Ax equal to 0. This part completed. Understood? What is the radius of curvature at maximum height? I am interested in maximum height. Radius of curvature at maximum height. This Vx or Vm equal to written as Ux equal to U cos theta. Ux equal to U cos theta. So what is explained here? First we need to draw perpendicular to this. Along this direction, this Vy equal to 0. Only one component, Vr. So draw perpendicular to this. Somewhere center O. We need to draw the circle. The circle fit into this. Understood? Draw the circle. Are you clear or not? This would be radius of curvature at maximum height. Radius of curvature at point of projection. If you draw free body diagram for this, weight acting vertically downward direction, centrifugal force always act away from the center of circular motion. This is O at point of projection. O at center of circular motion for maximum height. If the particle is at maximum height, Fc equal to how much? Fc equal to how much? M into corresponding Vm square by corresponding radius of curvature. Understood or not? Corresponding radius of curvature. If you draw free body diagram, radius of curvature at maximum height. Radius of curvature only at maximum height. At m. Understood? So if you draw free body diagram for the point mass at m, mg is balanced by whom? Centrifugal force. What is the velocity v? What is the velocity Vm? This is not a free body diagram, just U cos theta. Vm, don't represent this. Vm equal to how much? U cos theta. M into corresponding velocity square by corresponding radius of curvature. Understood? Sum of the upward force equal to sum of the downward forces. Sigma Fy equal to 0. Sum of the upward force equal to sum of the downward force. Fc equal to how much? Mg. Direct Mg. Weight acting downward direction. At any point, Mg component will be balanced by centrifugal force. Here, Mg. Fc equal to Mg. M into Vm square by radius of curvature at maximum height. Okay, so here what we will get, tell me? M gets cancelled out. Rm equal to how much? Corresponding Vm square by G. Vm can be written as U cos theta whole square by G. U cos theta whole square by G. U square cos square theta by G. What is the radius of curvature at maximum height? What is this Rm? Confidently tell me. What is this Rm? Tell me. u square cos square theta by g. u square cos square theta by g. u square cos square theta by g. This is radius of curvature at maximum height point at maximum height, radius of curvature at M. So here what is obtained at P, from at the point of projection how much is obtained? U square by g cos theta, u square by g cos theta. So this is at the radius of curvature at the point of projection. Radius of curvature at the point of projection. Radius of curvature at the point of projection. At the point of projection. Understood? Radius of curvature at the maximum height. This is the story. You have drawn free body diagram for the mass, which is in the projectile motion. Mass of the particle, okay, na mass of the ball. Weight always act vertically downward direction. Centrifugal force always act away from the center of circular motion. This is the center of circular motion when the particle is at maximum height. This is the center of circular motion when the particle is at point of projection. Weight acting downward. If it is theta, this would be theta. G cos theta will come here. Understood? This is mg cos theta, mg sin theta. So now mg cos theta, this is center away from the center of circular motion. Corresponding velocity is u. mu square by corresponding radius of curvature. Understood? Radius of the circular motion. Similarly, finally, what is obtained? U square by g cos theta. Even they ask velocity here. First calculate the velocity. U square by g cos theta. What is the theta? Direct theta will come. Understood? So you are in position to calculate radius of curvature at any point. Here also you are in position to calculate. Understood or not? This is the story of radius of curvature calculations in projectile motion. Next write down angular momentum of the particle. Angular momentum of the particle. Angular momentum of the particle. Calculations in projectile motion. Angular momentum. Angular momentum of the particle. Okay, calculations in projectile motion. Angular momentum is the momentum. Angular momentum. Angular momentum. Angular momentum calculations. This is L bar. Calculations in projectile motion. Clear? See this. Angular momentum calculations in projectile motion. This is x. This should be y. This should be y. Okay. So now the particle is projected like this. Particle is projected like this. So when the particle is at maximum height, when the particle is at maximum height, particle is at maximum height. What is the velocity of the particle at maximum height? Velocity of the particle at maximum height. It is projected with a velocity u. It is projected with a velocity u. This would be theta. Okay, that equal to how much? U cos theta. U cos theta. U cos theta. Along this direction, u cos theta. Ux is u cos theta. Along this direction, uy equal to u sin theta. uy equal to u sin theta, ux equal to u cos theta, vm equal to ux. Clear? What is the position of the particle with respect to the point of projection? With respect to the point of projection, position of the particle. This is the position of the particle. Position of the particle m with respect to point of projection. With respect to point of projection, this would be maximum height. This would be maximum height. H maximum, we can write it as H maximum j cap. H maximum j cap along this direction. Xm I cap along this direction. Xm I cap. Understood? What is the position of the particle? Here, angular momentum of the particle at maximum height with respect to the point of projection. That is the title. Angular momentum. Write down. Angular momentum. Angular momentum. Angular momentum of the particle. Angular momentum of the particle. Angular momentum of the particle. Okay na? Angular momentum of the particle. Yet maximum height. At maximum height m with respect to point of projection. With respect to point of projection P. With respect to point of projection P. L bar. Angular momentum is nothing but momentum. So that is nothing but L bar equals to m into how much you'll be getting? R bar cross V bar. R bar cross V bar. L bar equal to m into R bar cross V bar. Understood? Here, what is the position? So angular momentum of the particle at position m with respect to point of projection. That is nothing but m into position of the particle with respect to point of projection plus how much into how much cross how much velocity of the particle at maximum height. Understood? Position vector. How to take the position vector? That is from with respect to statement. What is the position of the particle? Tell me. Position of the particle at maximum height with respect to point of projection. What is that? Xm I cap plus maximum height j cap. Are you clear or not? Are you able to write this position vector? This is x I cap plus j cap. Okay na? Triangular law. Addition of two vectors. You can add these two vectors straight away. You will get R bar, position of the particle at maximum height with respect to point of projection. Clear? So now tell me what you will get. What is Vm bar? That equal to Vm. I cap. Clear? Position angular momentum of the particle at maximum height with respect to point of projection m into how much? This is how much? Xm I cap. This is how much? Xm I cap plus maximum height J cap, maximum height J cap crossed with VM I cap, I cap cross I cap 0, J cap cross I cap minus K cap. Okay, see this part will become 0 now. Here you can write L bar MP, that equal to how much? Xm into VM I cap cross I cap, that is 0 plus
minus
this is how much? H maximum into VM, H maximum into VM, J cap cross I cap, J cap cross I cap. Clear? This part becomes how much? This part becomes how much? 0. Finally, what is obtained? L. Position at point M with respect to point P. That equal to how much? M into VM into H maximum into minus K cap. Substitute all, you will get the answer. Substitute all. What is the H maximum? Tell me. What is the H maximum? Tell me. U square sin square theta by U square sin square theta by 2G. What is VM? U cos theta. What is the position of the particle? That equal to how much? M into U cos theta. M into U cos theta. H maximum equal to how much? U square sin square theta by 2G. U square sin square theta by 2G along negative Z axis. Write down up to here. Completed. So now angular momentum of the particle at maximum height. With respect to this. So finally how much is obtained? Lm about point of projection m into u cube by 2G m into u cube 2G sin square theta into cos theta minus K cap. Understood or not? Minus K cap means what? Negative Z axis. It is along negative Z axis. Along negative Z axis. If theta equal to 30 degrees, what you will get? If theta, point of projection, theta equal to 30 degrees, what is the answer? Tell me. Theta equal to 60 degrees you can take. Theta equal to 30 or 60, that is up to you. 30 degrees, what is the answer? With the point of projection, m into u cube by 2G into sin square 30 cos 30 sin square 30 cos 30 minus K cap. So root 3 by 2. This is 1 by 4. 8. How much is obtained? Root 3 mu cube by how much? 16G na. 16G. 1 by 2. 4. 4 2 is 8. 8 2 is 16. This is minus K cap. This is along this direction. It is very important. Along negative Z axis. Are you getting the same? U cos theta Here. So how to get the direction by using right hand thumb rule? How to get the direction by using right hand thumb rule? So this is along negative z axis or positive z axis. Negative. This part completed. Now here to here. How to get the direction by using right hand thumb rule? This part completed. Are you getting the same? MVR, M U cos theta, U square sin square theta by 2g. Okay, so M U cube sin square theta cos theta by 2g along negative z axis. So how to get this part? By using right hand thumb rule. Right hand thumb rule. See here, it's a mass. It's a mass. This is M. What is the position of the particle? Position of the particle with respect to this. Extend this vector. This is the velocity V. Okay na? Velocity V. Angle between them is what? Some angle. Clear? So here to here, some angle alpha you can take. Some angle. Clear up. So what is the position of? What is the L bar equal to how much? M into R bar cross V bar. R bar cross V bar. Understood? So here R bar, first R bar, next V bar. First R bar, next V bar. Then what you will get? First R bar, next V bar. What you will get? Angular momentum. Inward or outward? Inward or outward. First R bar, next V bar. What is the L bar? Tell me. What is the L bar? Tell me. Inward. This is L bar. Clear? Inward. So inward in the sense cross negative z axis. Negative z axis. This is inward or outward? Inward. First R bar, next V bar. First R bar, next V bar. Clear? First R bar, next V bar. R bar cross V bar. Straight away we can say position of the angular momentum. Angular momentum at maximum height with respect to point of projection. With respect to point of projection. Clear?